Hello everyone. Welcome to the series of video lectures for numerical matrix methods for solving the system of linear algebraic equations. Before we start, we should know what are the prerequisites for this topic. They are students should know the definition of a matrix, different types of matrices, elementary transformations, and determinant of a matrix, matrix algebra like addition, subtraction, multiplication of matrices, and what is the system of linear algebraic equations. The learning objectives of this series of video lectures are first to understand how to solve system of linear algebraic equations in the matrix form using numerical matrix method. Second is to understand how to write a programming code for these matrix methods. Third, to master the numerical methods like Cramer's rule, Gauss-Jordan method, Crowd's method, and Gauss-Seidel method for solving the system of linear algebraic equations. And last, to develop the analytical ability to apply these learnings to the real world problems. Now we should know what are the learning outcomes for this series of video lectures. First is students will be able to understand how to write a system of linear algebraic equations in the matrix equation form. Second, students will be able to understand and master the numerical methods like Cramer's rule, Gauss-Jordan method, Crowd's method, etc. Third, students will be able to write a programming code for these matrix methods. And last, students will develop the analytical ability to apply these learnings to the real world problems. So before we start, just let us recall what is the system of linear algebraic equations. As we can see that I have written m equations here in n unknowns, that is x1, x2 up to xn. So this system is called as a system of linear algebraic equations in m equations in n unknowns, and it can be written compactly in the matrix equation as Ax equal to b, where A is the coefficient matrix, X is the solution matrix, and B is the constant matrix. These are the numerical matrix methods that we will be covering in the series of video lectures. First is Cramer's rule, Gauss-Jordan method, Crowd's method, and Gauss-Seidel method. Okay, let us start with what is Cramer's rule. So for simplicity, let us consider a system of three equations in three unknowns given by these equations. Now let us rewrite this system into a matrix equation given in this way. So here this is the coefficient matrix, this is the solution matrix, and this is the constant matrix. So what we do next is this delta denotes the determinant, and this delta is nothing but this delta is nothing but determinant of this matrix A. So you can see that this and this is same, so delta is a determinant of this matrix. Let us denote delta 1. Okay, what do we do? Delta 1 is nothing but it is a determinant obtained by replacing the first column of this determinant with the constant matrix. Now delta 2 is nothing but the determinant we obtain by replacing the second column of this determinant with the constant matrix, and similarly when we replace the third column of this determinant by the constant matrix, we get delta 3. And finally the solution is given as x equal to delta 1 by delta, y equal to delta 2 by delta, and z is equal to delta 3 by delta. Let us solve a simple example here. So this system of equation is given to us. Now first what we do is we are going to rewrite this system into the matrix form. So this is my matrix A, this is the matrix of solution, that is X, and it is the matrix of constant, that is B. So once we do that, we are going to calculate the determinant of this matrix, that is delta. So I have already calculated it here. The answer is 3. So we have obtained delta Now let us go to the next slide and calculate delta 1. So I have already written this value, and calculation is already done, and we already know what is x. So what you can do right now is you can pause the video and go back to the previous slide and just check what is the definition of x. So now you know that definition of x is delta 1 by delta, and since delta 1 we have calculated as 3, so 3 upon delta is also 3, so therefore it is 1. Similarly, we can calculate delta 2 and delta 3. It is just obtaining the determinants. So we get this answer. Again here y is given as delta 2 by delta. If you want, you can pause the video for 1 minute and just check what was the solution given, that is this, and therefore 0 upon 3 is 0. And finally z is also given as delta 3 upon delta, that is 3 by 3 is equal to 1. So what I want you to do now is you pause the video right now, and then you can take one small example and try to solve it using Cramer's rule. So that's it for this lecture. And before I sign off, I would like to give you some information. If you want to practice more questions, and if you want to solve quizzes regarding this particular video, you can log into Moodle. I've given you the link of the Moodle site as well as the user ID and password. You can pause this video and you can note it down. And one more thing, on this Moodle site there will also be Scilab course for the matrix methods that I am going to teach you. So you can use those Scilab codes to test whether the matrix method or the solution that you have obtained is wrong or correct. So that's all for today. Thanks a lot, and please, if you have any doubts or any difficulties, you can leave a message on Moodle. I'll contact you. Thank you.